Hello everyone. In the beginning of the class, please pause the video and review the following problems. After you finish doing the problems, you can continue the video and I will show you all the solutions in detail. Okay, let's work together for these problems. First problem, 10x to the power 3, y to the power 5, minus 15, x to the power 6, y to the power of 4, over 5x squared, y to the power 4. When we try to simplify a rational expression, we try to factor completely first. Factor both the numerator and denominator first, then cancel the common factors. Let's factor the numerator first. For the numerator, there are two terms. I can try to factor out the common factors. Look at the number first. For 10 and 15, the greatest common factor is 5. That's the largest number that divides both 10 and 15. Then common letters. For the common letters, we have both x and y. For letter x, the lowest power is 3. For letter y, lowest power is power 4. If I pull out the greatest common factor, what's left here? 10 divided by 5 is 2. And I pull out x to the power 3 completely, and there's no x left. For y to the power 5 means there are 5 y's multiplied together. If I pull out 4 of them, there's one more y left here. Next, minus 15 divided by 5 is 3. X to the power 6 means there are 6x multiplied together. If I pull out 3 of them, the other 3 left inside. And we pull out y to the power 4 completely, there's no y left. On the denominator, we have 5x squared y to the power 4. When we try to simplify, I can first of all cancel number 5 from top and the bottom. Next, let's try to cancel x. We have x on the top and the bottom. Since the top x has larger power, we keep x on the top. Take larger power minus the smaller power. 3 minus 2 is 1. And for y's, they have exactly the same power. Since y on the top and the bottom have exactly the same power, they get cancelled. So the y's get cancelled completely. If everything on the bottom get cancelled, we write 1 on the bottom. On the top, we have 2y minus 3x cubed. For the final answer, if the denominator is 1, we don't write 1 on the denominator. For the final answer, if the denominator is 1, we don't write 1. And also, for x to the power 1, if the power is 1, we don't write 1. So the final answer is x times 2y minus 3s to the power of 3. That's the final answer. Next. Negative 18 x to the power 7 y to the power 6 plus 24 x to the power 5 y to the power of 8 over negative 6 x to the power 3 y to the power of 5. So when we try to simplify a rational expression, try to factor completely first, then cancel the common factors. Factor completely first, then cancel the common factors. On the numerator, there's only 2 terms. When we try to factor, we can try to pull out the common factors. For 18 and 24, the greatest common factor is 6. Common letters are x and y. For letter x, the lowest power is power 5. For letter y, the lowest power is power 6. Since the leading term is negative, we pull out negative sign when we are factoring. Since if the first term is negative, we need to pull out negative sign. Then after factoring, what's left here is negative 18 divided by negative 6 is positive 3. We have 7x multiplied together. X to the power 7 means there are 7x multiplied together. If we pull out 5 of them, we have 2 more left here. And we pull out y to the power 6 completely. For the second half, positive 24 divided by negative 6 is negative 4. We have x to the power 5 here, but we pull out x to the power 5 completely, so there's no x left. We have y to the power 8. If we pull out 6 of them, that means there are 8 y's multiplied together. If we pull out 6 of them, we have 2 more y left here. The denominator cannot be factored, we leave it the same. Then let's do cancellation. We can cancel negative 6 from top and the bottom. And for x, we have x to the power 5 on the top, x to the power 3 on the bottom. If we try to cancel, we use larger power minus smaller power. Since the top has larger power, keep x on the top. Use larger power minus smaller power. 5 minus 3 is 2. Now same thing for letter y. Let's compare the power. We can see that here, the y on the top has larger power. So keep y on the top. Then use larger power minus smaller power. 6 minus 5 is 1. After cancellation, leave the parentheses the same. If there's nothing left on the denominator, write 1 on the bottom. For the final answer, if the denominator is 1, we don't write 1 on the denominator. So the final answer is x squared y. Y to the power 1 is the same as y. Times 3x squared minus 4y squared. That's the final answer. Next. Tx minus 3t over 2ty plus at. Tx minus 3t over 2ty plus at. So when we try to simplify a rational expression, factor first. Try to factor first, then cancel common factors. On the numerator, the common factor is t. I can pull out t. If I pull out t, what's left is x minus 3. On the denominator, common factor for number 2 and number 8, the common factor is 2. That's the largest number that divides both of them. And t is a common letter, I can pull out t. If I pull out 2t, what's left here? For the first term, if I pull out 2t, what's left is letter y. For the second term, 8 divided by 2 is 4. And there's only one t. If I pull out t, then there's no t left. Then here, let's observe what can we cancel here from top and the bottom. The only common factor here is t. The only common factor on the top and the bottom is t. I can cancel t from top and the bottom. If I cancel t, I have x minus 3 on the top and 2 times y plus 4 on the bottom. That's the final answer. Next, axy plus 4y squared over net 14x squared minus 7sy. Axy plus 4y squared over negative 14x squared minus 7sy. When we try to simplify a rational expression, we try to factor first, then do the cancellation. Let's factor first. On the numerator, for number 8 and number 4, the greatest common factor is 4. That's the largest number that divides both 8 and 4. Common letter is y. And we can pick the lowest power. For letter y, lowest power is power 1. Pull out 4y. 8 divided by 4 is 2. If I pull out y, we only have x left. For the second term, 4 divided by 4 is 1. And y squared means there are two y's multiplied together. If I pull out one of the y's, another y left here. We have 2x plus 1y. We have 2x plus 1y. For any polynomial, if the coefficient is 1, usually we don't write 1. 1y is the same as y. So I replace 1y with y. 1y is the same as y. That's the numerator. On the denominator, we can also try to pull out the common factors. For 14 and 7, common factor is 7. And common letter is x. And for x, we pick the lowest power. Lowest power is power 1. Since the first sign is negative, when we factor, we need to pull out negative sign. Since the first sign is negative, when we factor, we need to pull out negative sign. Now, what's left? Negative 14 divided by negative 7 is positive 2. X squared means there are 2x multiplied together. If we pull out one of them, the other one left here. Second part. Negative 7 divided by negative 7 is positive 1. Negative 7 divided by negative 7 is positive 1. There's only one x. If I pull out x, then there's no x left. But letter y stays the same. So we get 2x plus 1y. And we know that for any polynomial, if the coefficient is 1, we don't write 1. Here, 1y is the same as y. 1y is the same as y. Then let's do the cancellation. 2x plus y on the top and the bottom looks exactly the same. 2x plus y on the top and the bottom looks exactly the same. So we can cancel 2x plus y. After cancellation, what's left here is 4y over 7x, negative 7x. 4y over negative 7x. We have a positive number divided by negative number, which is negative. 4 and 7 cannot be simplified. X and y also, they are different letters on the top and the bottom, they cannot be simplified. So the final answer is negative 4y over 7x. That's the final answer in the simple list form. Next. X squared plus 7x plus 12 over x squared minus 9. So same procedure. We try to factor first. Try to factor completely first. Then cancel common factors. On the numerator, it's a trinomial with no leading coefficient. So we draw two parentheses. I can first of all split x squared into x times x. We must split x squared evenly. So x times x is x squared. Next, try to find two numbers that they multiply to be 12 and they add to be positive 7. Try to find two numbers that they multiply to be positive 12 and when we add, we get positive 7. For 12, we can try 3 and 4. Since we want to get positive 7 here, we use positive 3 and positive 4. When we add the number, we get positive 7. When we multiply, positive 3 times positive 4 is positive 12. So this two number works. We put these two numbers in the parentheses. X plus 3, x plus 4. Denominator, x squared minus 9. X squared minus 9, they are perfect squares. X squared minus 9. X squared minus 9. X squared is a perfect square. 9 is also a perfect square. 3 times 3 is 9. Since they are perfect squares, we can use the formula a squared minus b squared equal to a plus b times a minus b. This formula is called difference of perfect squares, and we have it here. So we use the formula, we have a plus b times a minus b. A plus b times a minus b. Use the formula here. X plus 3 x minus 3. Cancel x plus 3 from top and the bottom. They look exactly the same. I can cancel. X plus 3 looks exactly the same. I can always cancel the common factors from top and the bottom. What's left is x plus 4 over x minus 3. That's the final answer. Next, 2x squared plus 2 plus 9y. Two x squared plus 9x plus 4 over 2x squared minus 5x minus 3. Same thing, we try to factor first. When we try to simplify rational expression, try to factor both the numerator and denominator first, then cancel the common factors. Let's factor. 2x squared plus 9x plus 4. When we have a trinomial, we can try to use AC method. These three numbers, they are called A, B, C. If I multiply AC, 2 times 4 is A. Can we find two numbers that when we multiply, we get A. When we add, we get positive 9. We can try to use 1 and A. Since I try to get positive 9 here, I can use positive 1 and positive A. When I add the numbers, positive 1 plus positive A is positive 9. When I multiply, positive 1 times positive A is A. So, these two numbers works. I can replace the middle term with these two numbers. So I use positive 1 and positive A as coefficient. Letters stays the same, the variable stays the same. Positive 1x, positive ax plus 4. Now we get 4 terms. When there are 4 or more terms, we can try to factor by grouping. For the first two terms, for number 2 and 1, common factor is 1. Common letter is x. And lowest power is 1. It's x to the power 1. If I pull out 1x, what's left here? 2 divided by 1 is 2. X squared means there are 2x. If I pull out one of them, another x left here. Second part. 1 divided by 1 is 1. There's only 1x. If I pull out x, then there's no x left. That's the first half. For the first half here, we have 1x. For any polynomial, if coefficient is 1, we don't write 1. 1x is the same as x, so I can replace 1x with x. Look at the second half. Ax plus 4. The greatest common factor is 4. If I pull out 4, a divided by 4 is 2. Letter x stays the same. 4 divided by 4 is 1. Then here we can see that 2x plus 1 is a common factor. 2x plus 1 is a common factor. If I pull out 2x plus 1, what's left is x plus 4. That's the numerator. That's the numerator after I factor. So the numerator after I factor is 2x plus 1 times x plus 4. And that's the numerator. Next, we can try to factor the denominator exactly the same way. Next, let's factor the denominator exactly the same way. Use AC method. 2x squared minus 5x minus 3. We first of all multiply AC. 2 times negative 3 is negative 6. Next, we try to find two numbers. Like when we multiply, we get negative 6. When we add, we get negative 5. Try to find two numbers. When we multiply, we get negative 6. When we add, we get negative 5. Let's try 2 and 3 first. Since we try to get negative 5, we can use negative 2 and negative 3 Negative 2 plus negative 3 is negative 5. But I think it's when we multiply, negative 2 times negative 3 is positive 6. It doesn't match negative 6 here. When we multiply, we don't get negative 6. So 2 and 3 doesn't work. Let's try a different pair. If 2 and 3 doesn't work, another possibility is 1 and 6. Since I try to get negative 5 here, I can use positive 1 and negative 6. Positive 1 plus negative 6 is negative 5. When I multiply, positive 1 times negative 6 is negative 6. So this pair works. I keep the first term the same. Rewrite the middle term using these two numbers. We have positive 1x minus 6x minus 3. Last term stays the same. For the middle term, we use these two numbers as coefficient. The variable stays the same. Now we have 4 terms. We can filter this by grouping. For the first 2 terms, take out common factor. Let's first of all take out common factor for the numbers. For number 2 and 1, the greatest common factor is 1. Common letter is x. We pick the lowest power. We have power 2 and power 1. Lowest power is power 1. If I pull out 1x, 2 divided by 1 is 2. X squared means there are 2x multiplied together. If I take out one of them, the other one stays there. For the second term, 1 divided by 1 is 1. There's only 1x. If I pull out x, then there's no x left. And be very, very careful. For polynomial, if the coefficient is 1, we don't write 1. 1x is the same as x. For the second half here, for 6 and 3, the greatest common factor is 3. The greatest common factor is 3. Since the first term is negative, we pull out negative sign. And here we see that there's no common letters. So negative 3 is the greatest common factor. If I pull out negative 3, negative 6 divided by negative 3 is positive 2. X stays the same. Next term, negative 3 divided by negative 3 is positive 1. That's the second half. After factoring, we can see that 2x plus 1 is a common factor. 2x plus 1 is a common factor. So we pull out the common factor. Pull out 2x plus 1. What's left is x minus 3. If I pull out 2x plus 1, what's left is x minus 3. That's the denominator. That's the denominator after we factoring. That's the denominator after we factoring. So 2x plus 1 over x minus 3. So here we factor both the numerator and denominator. Then we do the cancellation. Observe these two terms. Observe the top and the bottom. We can see that here 2x plus 1 on the top and the bottom looks exactly the same. 2x plus 1 looks exactly the same on the top and the bottom. So I can cancel the common factors. If I cancel the common factor, what's left is x plus 4 over x minus 3. That's what's left. Next, 2x minus 3 over 3 minus 2x. So in general, for rational expression, we try to factor the top and the bottom first. For this problem, if we try to factor the top and the bottom, we can see that both top and the bottom cannot be factored. Let's observe carefully. They cannot be factored, but the terms on the top and the bottom looks exactly the same. The terms on the top and the bottom looks exactly the same, but they have opposite orders. And remember, a plus b, for addition, a plus b is always the same as b plus a. For addition, if I switch order, everything stays the same. But for subtraction, a minus b, if I switch order, it becomes negative b minus a. For subtraction, if I switch order, it becomes b minus a. So here, I try to rewrite the bottom. The bottom is 3 minus 2x. I try to write x in the front. I try to rewrite the bottom, put x in the front. That's a little easier. Rewrite the bottom, put x in the front. It can be rewritten as negative 2x minus 3. If I interchange the terms, I change the sign. So 3 minus 2x become negative 2x minus 3. Usually we try to put x in the front. That's a little easier. So rewrite the bottom as negative 2x minus 3. Rewrite the bottom as negative 2x minus 3. Leave the top the same. Now you can see that 2x minus 3 looks exactly the same. If I cancel 2x minus 3, there's nothing left on the top. If there's nothing left, we need to write 1 on the top as a placeholder. Same thing on the bottom. If I cancel 2x minus 3, there's nothing left. If there's nothing left, we write 1 as a placeholder. We can leave it blank. Write 1 as a placeholder. Then we have positive 1 divided by negative 1. When we divide two numbers with different sign, answer is negative. 1 divided by 1 is 1. So the answer is negative 1. Next. Nine x squared minus 16y squared over ay minus 6x. So when we try to simplify rational expressions, we try to simplify, factor both top and bottom first. Let's observe the top. How can we factor the top? If we observe the top, we can see that 9 is a perfect square. X squared is also perfect square. 16 is perfect square. Y to the power 4 is also perfect square. If they are all perfect squares, we can use the formula a squared minus b squared equal to a plus b times a minus b. So let's rewrite the formula. We have 9x squared minus 16y squared. 9 is 3 squared. 3 times 3 is 9. X squared can be rewritten as x times x. So 9x squared can be rewritten as 3x squared. 16 is also perfect square. 4 times 4 is 16. So 16 can be written as 4 squared. Y squared is y times y. So 16y squared can be rewritten as 4y squared with a parenthesis. Then apply the formula. 3x represent a, 4y represent b. Use the formula a plus b times a minus b. Then that's an answer. So factor the numerator, I get this. Factor the numerator, I get 3x plus 4y, 3x minus 4y. For the denominator, ay minus 6x, ay minus 6x. I can try to factor here. Common factor here for a and 6 is 2. That's the largest number that divides both a and 6. If I pull out 2, a divided by 2 is 4. Y stays the same. 6 divided by 2 is 3. X stays the same. Now, can we cancel anything out? Observe here. Can we cancel anything out? This part looks almost the same as this part here. They have exactly the same terms, but opposite order. So for subtraction, if I switch order, I add negative sign in the front. So usually we try to write x in the front. That's a little easier. Write x in the front. So on the bottom, if I switch order, put x in the front, I add negative sign in the front. If I switch order, add negative sign to the front. If I switch order, I add negative sign to the front. So positive 2 becomes negative 2. 4y minus 3x becomes 3x minus 4y. The numerator stays the same. Now I can cancel 3x minus 4y. So for the final answer, For the final answer, let me put it here. We have 3x minus plus 4y on the top, negative 2 on the bottom. Then positive term, the top is positive. Positive term divided by negative term is negative. Put negative in the front. We have 3x plus 4y over 2. That's the final answer. Next. (5x minus 15) over negative x plus 3. So when we try to simplify rational expression, try to factor both top and bottom first. If we try to factor the top, on the top I can try to factor number 5 out. That's the largest number that divides both 5 and 15. For the first term, if I pull out 5, that's x left. For the second term, take 15 divided by 5, that's 3. That's the numerator. On the denominator, we have negative x plus 3. If there's no coefficient, we assume the coefficient is 1. So for negative x plus 3, if there's no coefficient, we assume coefficient is 1. Then for negative 1 and 3, common factor is 1. Greatest common factor is 1. That's the largest number that divides both 1 and 3. Since the first term is negative, when I factor, I need to pull out negative sign. For the first term, if I pull out negative 1, what's left is x. For the second term, we take positive 3 divided by negative 1, which is negative 3. So that's the factorial form of the denominator. If I factor the denominator, I get this. Negative 1 times x minus 3. Then on the top and the bottom, we can see that x minus 3 looks exactly the same. I can cancel x minus 3. What's left is negative 5. What's left is 5 over negative 1. Positive 5 over negative 1 is negative 5. That's the final answer for number 9. Number 10. 1 minus 4x squared over 6x squared plus x minus 2. So when we try to simplify rational expression, try to factor both top and bottom first. If we try to factor the top, we can see that here. 1 minus 4x squared. 1 is a perfect square. 4 is also a perfect square. We have subtraction in the middle. Imagine a form of difference of perfect square. So number 1 can be rewritten as 1 square. 4 can be rewritten as 2 times 2. So 4 is 2 square. X squared can be rewritten as x times x. So 4x squared can be rewritten as 2x squared in parentheses. Then imagine the difference of perfect squares. 1 represents A, 2x represents B. Use the formula, we have A plus B times A minus B. That's the numerator. That's the factorial form of the numerator. 1 plus 2x times 1 minus 2x. That's the factorial form of the numerator. For the denominator, we have 6x squared plus x minus 2. This is a trinomial, and there is a leading coefficient. We can try to use an AC method. A times c here. If I take a times c, 6 times negative 2 is negative 12. Can we find two numbers? Can we find two numbers that they multiply to be negative 12 and they add to be positive 1? If there's no coefficient, we assume coefficient is 1. Can we find two numbers that they multiply to be negative 12 and they add to be positive 1? For number 12, we can try to use 3 and 4. If we try to make positive 1 here in the middle, I can use negative 3 and positive 4. Negative 3 plus positive 4 is positive 1. And negative 3 times positive 4 is negative 12. Then we can use these two numbers to replace the middle term. Keep first term the same. Replace the middle term with negative 3x plus 4x. Leave the last term the same. Now we have 4 terms. When there are 4 terms, we can try to factor by grouping. For the first 2 terms, we can try to pull out a common factor. The number divides both 3 and 6 is 3. That's the largest number that divides both 6 and 3. Common letter is x. That's the common variable. If I pull out 3x, first term, 6 divided by 3 is 2. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Second term, 3 divided by 3 is 1. There's only 1x. If I pull out x, there's nothing left. That's the first half. For the second half, factor, take out the common factor. For 4 and 2, the greatest common factor is 2. That's the largest number that divides both 4 and 2. If I pull out 2, 4 divided by 2 is 2. X stays the same. 2 divided by 2 is 1. So we can see that here. 2x minus 1 is common factor. After we factor, we can see that 2x minus 1 is a common factor. If I pull out 2x minus 1, what's left is 3x plus 2. If I pull out 2x minus 1, what's left is 3x plus 2. So that's the factor form of the denominator. This is the factor form of the denominator. Put it on the bottom. We have 2x minus 1 times 3x plus 2. Now if we observe the top and the bottom, can we cancel anything out? For these two parts, it looks like they have exactly the same terms, but opposite order. For these two factors, they have exactly the same terms, but opposite orders. So we can try to switch order for one of them. Usually we try to write x in the front. Usually try to switch order, write x in the front. How do we switch order here? For addition, a plus b is always the same as b plus a. For addition, a plus b is always the same as b plus a. So for addition, if I switch order, I don't make any change. So 1 plus 2x is the same as 2x plus 1. That's for addition. Now for subtraction, if I switch order, I add negative sign in the front. For subtraction, if I switch order, I add negative sign in the front. So times 1 minus 2x. Then this is positive, times 2x minus 1. Add negative sign to the front, then switch order. Now, this is a positive term. This is a negative term. When we multiply, positive term times negative term is negative. And we multiply these two terms together. Multiply these two factors together. 2s plus 1, 2s minus 1. That's the numerator after I switch order. The numerator can be rewritten as negative 2s plus 1, 2s minus 1. The denominator is 2s minus 1 times 3s plus 2. Then we can cancel 2s minus 1. For the final answer, top is negative, bottom is positive. Negative number divided by positive number is negative. After cancellation, what's left on the top is 2s plus 1. What's left on the bottom is 3x plus 2. That's the final answer. Next. X squared plus 3x minus 10 over x squared minus 6x plus a times x squared minus 7x plus 12 over x squared plus 6x plus 5. So when we try to multiply rational expressions, we try to simplify each top and bottom individually. When we multiply rational expressions, try to factor each numerator and denominator individually. Factor first, then do cancellation. Let's factor the first numerator here. First numerator, we have x squared plus 3x minus 10. x squared plus 3x minus 10. So this is a trinomial and there's no leading coefficient. We can write two parentheses, split x squared, write x on each parenthesis. Can we find two numbers that they multiply to be negative 10 and add to be 3? Can we find two numbers that they multiply to be negative 10 and they add to be 3? We can try to use 2 and 5. For number 10, I can factor 10 as 2 and 5. Since I try to get positive 3 here, I can use negative 2 and positive 5. Negative 2 times positive 5 is negative 10. But when we add negative 2 plus positive 5 is positive 3. So this two number works. We can put it in the parentheses. Negative 2, positive 5. That's the factor form of the numerator. Now the denominator. Same thing, this is a trinomial with no leading coefficient. So you can draw two parentheses, split x squared evenly, put x on each parenthesis. Now, can we find two numbers that they multiply to be a? And when we add, we have 6 here. Can we find two numbers that when we multiply, we get a? When we add, we get negative 6. Can we find two numbers that when we add, when we multiply, we get a? When we add, we get 6. We get negative 6. For number 8, we can try 2 and 4. Since I try to get negative 6 here, I can use negative 2 and negative 4. Negative 2 plus negative 4 is negative 6. And when we multiply, negative 2 times negative 4 is positive a. So I can put negative 2 and negative 4 in the parentheses. Negative 2, negative 4. Next. For the second rational expression, let's factor the numerator. Same thing, this is a trinomial with no leading coefficient. We can draw two parentheses, split x squared, put x on each parenthesis. Now, try to factor 12. Can we find two numbers that they multiply to be 12? And when we add, we get negative 7. Can we find two numbers that when we multiply, we get negative 2, we get positive 12? When we add, we get negative 7. For 12, we can try 3 and 4. Since I try to get negative 7 in the middle, I can use negative 3, negative 4. Let's check. Negative 3 plus negative 4 is negative 7. When we multiply, negative 3 times negative 4 is positive 12. So this two number works. Negative 3, negative 4. That's the numerator. Now factor the denominator. Again, this is a trinomial with no leading coefficients. This is a trinomial with no leading coefficient. So you can draw two parentheses. Split x evenly, put it in the parentheses. X squared can be split as x times x. Now, can we find two numbers that they multiply to be 5 and they add to be 6? Can we find two numbers that they multiply to be 5 and they add to be 6? We can try 1 and 5. Positive 1, positive 5. When we add, we get positive 6. When we multiply, we get 5. So 1 and 5 works. We can put it in the parentheses. Positive 1, positive 5. Now, try to cancel common factors. Cancel common factors from top and bottom. I can first of all cancel s minus 2 from top and bottom. I can cancel s plus 5 from top and bottom. I can cancel s minus 4 from top and bottom. What's left is s minus 1 over x plus 1. X minus 3 over x plus 1. So the final answer is x minus 3 over s plus 1. After cancellation, that's what's left, and that's the final answer. Next, negative 3x to the power 3 plus 12x squared minus 9x times x squared plus 6x plus 5 over 6x to the power 3 minus 6x. When we multiply a polynomial with a rational expression, usually we treat polynomial as a whole number, treat rational expression as a fraction. When we multiply whole number to fraction, we put the whole number over 1. In general, put the whole number over 1. Negative 3x to the power 3 plus 12x squared minus 9x. Put the whole number over 1. Leave the fraction the same. Then we try to factor every numerator and denominator. Try to factor every numerator and denominator. Let's look at the first numerator here. How do we factor the first numerator? First numerator here is negative 3x to the power 3 plus 12x squared minus 9x. When we factor, we try to pull out the greatest common factor. When we factor, try to pull out the greatest common factor. Here, for 3, 12, and 9, the greatest common factor is 3. Common letter is x. Common letter is x. We pick the lowest power. Lowest power is power 1. Since the first term is negative, we have to pull out negative sign. For the first term, if I pull out negative 3, I take negative 3 divided by negative 3, which is positive 1. X to the power 3 means there are 3x multiplied together. If I pull out one of them, we have 2 more left here. Second term, we have positive 12 divided by negative 3. Positive 12 divided by negative 3 is negative 4. There are 2x here. There are 2x multiplied together. If I pull out one of them, the other x left inside. The third term, take negative 9 divided by negative 3, which is positive 3. There's only one x. If I pull out x, there's no x left. Now, for polynomials, if the coefficient is 1, usually we don't write 1. If the coefficient is 1, we don't write 1. So, first term, 1x squared is the same as x squared. Then factor, this is a trinomial. And there's no leading coefficient, so I draw 2 parentheses. Put x on each parentheses. Then try to find 2 numbers that when we multiply, we get 3. When we add, we get negative 4. For number 3, you can try to use 1 and 3. Since we try to get negative 4 here, I can use negative 1 and negative 3. Negative 1 plus negative 3 is negative 4. When I multiply, negative 1 times negative 3 is positive 3. So this 2 number works. I can put this 2 number in the parentheses, negative 1, negative 3, and leave negative 3x the same. So that's the factorial form of the numerator. That's the factorial form of this numerator. Negative 3x times s minus 1 times x minus 3. That's the factorial form of the numerator. The denominator is number 1. That's not factorable. I leave it the way it is. Second fraction. For the numerator, s squared plus 6x plus 5. S squared plus 6x plus 5. This is a trinomial. And there's no leading coefficient. I can draw 2 parentheses, put x on each parenthesis. Then we try to find 2 numbers that when we multiply, we get 5. When we add, we get 6. For number 5, only possibility is 1 and 5. For number 5, only way to factor 5 is 1 and 5. And since we try to get positive 6 here, I can add 1. I can do positive 1, positive 1, and positive 5. When I add, positive 1 plus positive 5 is positive 6. And when I multiply, positive 1 times positive 5 is 5. So this 2 number works. I can put these 2 numbers in the parentheses, positive 1 and positive 5. That's the numerator. Now denominator, we have 6x to the power 3 minus 6x. 6x to the power 3 minus 6x. We can try to pull out common factor first. 6 is the common factor for both 6. That's the largest number that divides both 6. X is a common letter, common variable. Lowest power is power 1. If I pull out 6x, for the first term, if I pull out 6, there's no number left. There are 3x. If I pull out 1 of x, I have 2 more x left here. For the second term, 6 divided by 6 is 1. There's only one x. If I pull out x, there's no x left. So what's left here is x squared minus 1. Now if we observe carefully, we can see that x squared is a perfect square. That's x squared. That's x squared. Number 1 can be rewritten as 1 squared. Number 1 can be rewritten as 1 squared. So let's call difference of perfect squares. We can use the formula. A squared minus b squared equal to a plus b times a minus b. We can use the formula here. X represents a, 1 represents b. If I use the formula, I have x plus 1 times s minus 1. And leave 6x the same. That's the factor form of this denominator. That's the factor form of this denominator. Put it here. 6x times x plus 1 times s minus 1. Factor completely. Then we try to cancel common factors. We can cancel x minus 1 from top and bottom. Cancel s minus 1 from top and bottom. We can cancel x plus 1 from top and bottom. We can cancel this x from top and bottom. So what's left on the top? We have negative 3. This can cancel. We have x minus 3 on the top times x plus 5 on the top. On the bottom, we have number 1 and number 6 left. 1 times 6 is 6. If I simplify here, we can see that negative number divided by positive number is negative. For 3 and 6, I can divide both numbers by 3. For 3 and 6, I can divide both numbers by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. The rest stays the same. X minus 3, s plus 5 stays the same. Then for the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. So that's your final answer for number 12. Number 13. X squared minus x minus 12 divided by 2x to the power 3 minus 18x divided by x squared minus 16 over 5x squared plus 20x. When we have division for rational expressions, we keep the first fraction the same. Change division to multiplication, then flip the second fraction over. We treat rational expression as fractions. Keep the first fraction the same. S squared minus x minus 12. Keep the first fraction the same. Change division to multiplication, then flip the second fraction over. 5x squared plus 20x over x squared minus 16. When we try to divide, we keep the first fraction the same. Change division to multiplication, then flip the second fraction over. Then we factor each numerator and denominator. Factor each numerator and denominator. First numerator, x squared minus 12, x squared minus x minus 12. This is a trinomial. This is a trinomial with no leading coefficients. I can write two parentheses. X times x is x squared. Split x squared as x times x. Now try to find two numbers that when we multiply, we get negative 12. When we add, we get negative 1. Try to find two numbers that when we multiply, we get negative 12. When we add, we get negative 1. We can try to use 3 and 4. Since I try to get negative 1 here, I can use positive 3, negative 4. When I add, positive 3 plus negative 4 is negative 1. When I multiply, positive 3 times negative 4 is negative 12. So I can use positive 3 and negative 4 in the parentheses. Positive 3, negative 4. For the denominator, we have 2x cubed minus 18x. 2x cubed minus 18x. (2x cubed minus 18x). I can first of all pull out the greatest common factor. For 2x cubed and 18x, the greatest common factor is 2. That's the largest number that divides both 2 and 18. Common letter is x. Pull out x. What's left here? For 2x cubed, if I pull out 2, there's no number left. X cubed means there are 3x multiplied together. If I pull out one of them, the other 2 left here. For the second term, keep negative sign. 18 divided by 2 is 9. There's only one x. If I pull out x, then there's no x left. Here we have x squared minus 9. X squared minus 9, that's called difference of perfect squares. X squared is x squared. X squared is x times x, that's x squared. Number 9 can be rewritten as 3 times 3. Number 9 can be rewritten as 3 times 3, so that's 3 squared. This is in the form of difference of perfect squares. It can be rewritten as x plus 3 times x minus 3. This can be rewritten as x plus 3 times x minus 3. If we keep 2x the same, that's the factor form of the denominator. This is the factor form of the denominator. So after we factor the denominator, we have 2x times x plus 3 times x minus 3. That's the factor form of the denominator. Now, for the second fraction, for the numerator, we have 5x squared plus 20x. 5x squared plus 20x. I can try to pull out the common factors. For 5x squared and 20x, the common factor between 5 and 20 is 5. That's the largest number that divides both 5 and 20. Common letter is x. Common variable is x. If I pull out 5x, for the first term, if I pull out 5, there's no number left. X squared means there are 2x multiplied together. If I pull out one of them, the other one left inside. Second term, 20 divided by 5 is 4. That's only one x. If I pull out x, then there's no x left. That's the factor form of this numerator. For the denominator, we have x squared minus 16. X squared minus 16. X squared is a perfect square. That's x times x. 16 is also a perfect square. 4 times 4 is 16. So 16 can be rewritten as 4 squared. Then use the formula. This can be rewritten as x plus 4 times s minus 4. That's the factor form of the denominator. Put it here. S plus 4 times s minus 4. So here we factor every numerator and denominator. Then we try to do cancellation. I can cancel x plus 3 from top and bottom. I can cancel s minus 4 from top and bottom. I can cancel s plus 4 from top and bottom. I can cancel letter x from top and bottom. Cancel letter x from top and bottom. What's left on the top? What's left on the top is number 5. Everything got cancelled. Only number 5 left on the top. On the bottom, what's left is number 2 and x minus 3. On the bottom, what's left is number 2 and x minus 3. Then, since nothing can be cancelled out, that's the final answer. Next one. 2x to the power 3 plus 6x squared plus 4x over 10x plus 10 divided by 5x to the power 3 minus 20x. So when we're doing division, when we have rational expression divided by polynomial, we treat rational expression as fraction, treat polynomial as whole number. When we have fraction divided by whole number, we first of all pull the whole number over 1. Keep the fraction the same and write the whole number over 1. We have 2x cubed plus 6x squared plus 4x over 10x plus 10 divided by 5x cubed minus 20x over 1. We first of all put the fraction over 1. Next, first of all put the polynomial over 1. Next, when we're doing division for rational expressions, we keep the first fraction the same. Change division be multiplication and flip the second fraction over. So keep the first fraction the same. Change division to multiplication. Flip the second fraction over. Then simplify. Then factor. Factor each numerator and denominator. Factor each numerator and denominator. Then cancel common factors. Let's factor the first numerator. First numerator 2x cubed plus 6x squared plus 4x. Let me put it here. 2x cubed plus 6x squared plus 4x. If I factor its numerator, I can try to pull out common factor first. I can pull out 2x. If I pull out 2x, 2 is the greatest common, 2 is the largest number that divides all three numbers, 2, 4, and 6. X is the common letter, and we pick the lowest power. Lowest power is power 1, so 2x is the greatest common factor. For the first term, if I pull out 2, there's no number left. X cubed means there are 3x multiplied together. If I pull out one of them, we have 2 more left inside the parentheses. For the second term, if I take 6 divided by 2, I have 3. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Last term, 4 divided by 2 is 2. There's only one x. If I pull out x, there's no x left. Then this is a trinomial. And there's no leading coefficient. I can try to factor this. Split x squared, write x, put x on each parenthesis. Then last number is 2. We try to factor 2. Find two numbers that they multiply to be 2 and they add to be positive 3. We can try positive 1 and positive 2. When I add the numbers, positive 1 plus positive 2 is positive 3. When I multiply, 1 times 2 is 2. So this two number works. Put both numbers in the parentheses. We have 2x times x plus 1 times x plus 2. That's the numerator after factor. That's the numerator. For the denominator, 10x plus 10. 10 is the common factor. I can pull out 10. 10 is the common factor. That's the largest number that divides both 10s. If I pull out 10, for the first term, if I pull out 10, there's x left. For the second term, 10 divided by 10 is 1. So I factor the denominator here. Next, factor the second fraction. For the numerator, it's number 1. Number 1 cannot be factored. I leave it the way it is. For the denominator, 5x cubed minus 20x. 5x cubed minus 20x. Let's pull out the greatest common factor first. For 5 and 20, the greatest common factor is 5. Common letter is x, and we choose the lowest power. Lowest power is power 1. If I pull out 5x for the first term, if I pull out 5, there's no number left. X to the power 3 means there are 3x multiplied together. If I pull out one of them, we have 2 more left. Second term, negative 20 divided by 5 is negative 4. There's only one x. If I pull out x, there's no x left. So here we have x squared minus 4. Now observe. S squared is a perfect square, that's s squared. Number 4 can be rewritten as 2 times 2, so that's 2 squared. Then this is in the form of difference of perfect squares. It can be rewritten as s plus 2 times s minus 2. Then bring 5x down. That's the factor form of the denominator. That's the factor form of the denominator. So we have 5x times s plus 2 times x minus 2. After we factor everything completely, we try to cancel common factors. I can first of all cancel x plus 1. Then I can cancel s plus 2 from top and bottom. I can also cancel letter x from top and bottom. After cancellation, what's left on the top is number 2. 2 times 1 is 2. What's left on the top is number 2 and number 1. 2 times 1 is 2. On the bottom, we have number 10 and number 5. 10 times 5 is 50. 10 times 5 is 50. Everything can cancel. Only factor left here is x plus 2. Sorry, x minus 2. That's the only factor left on the bottom. 10 times 5 is 50. X minus 2 stays the same. Then for 2 over 50, I can try to cancel the numbers. For 2 and 50, I can divide both numbers by 2. For 2 and 50, I can divide both numbers by 2. 2 divided by 2 is 1. 50 divided by 2 is 25. So that's the final answer. Last class, I showed you multiplication and division of rational expressions. Today, I'll show you addition and subtraction of rational expressions. Addition and subtraction of rational expression is very similar as we're doing addition and subtraction for fractions. Addition and subtraction of rational expression is very similar as we're doing addition and subtraction for fractions, since we treat rational expression as fractions. Let's look at a very simple example. For example, 2 plus 7, 2 over 7 plus 4 over 7. When we are adding two fractions with the same denominator, we keep denominator the same and the numerator. When we are doing subtraction, 5 over 11 plus 2 over 11, we keep denominator the same and the numerator. 5 plus 2 is 7. For subtraction, it's the same. 9 over 13 minus 5 over 13. If two fractions has the same denominator, we keep denominator the same. Subtract the numerator. 9 minus 5 is 4. So doing addition, subtraction for rational expression is very similar as we adding and subtracting fractions. Let's look at a simple example first. S plus 1 over s plus 2 plus x plus 3 over s plus 2. When we are adding fractions with the same denominator, we keep denominator the same and add the numerator together. On the numerator, we can try to eliminate the parentheses first, then combine like terms. If I eliminate the parentheses, I have s plus 1. If there's nothing in the front, we can drop parentheses without making any change. If there's addition in the front, we can also drop the parentheses without making any change. We have x plus 3 here over s plus 2. Then we can combine like terms. On the top, x plus x is 2x. 1 plus 3 is 4 over x plus 2. Then we can try to factor the numerator. For the numerator, 2x plus 4. I can try to factor 2 out. 2 is the largest number that divides both 2 and 4. If I factor 2 out, I have x plus 2. If I factor 2 out, I have x plus 2 over x plus 2. Then I can cancel x plus 2 from top and the bottom. The final answer is number 2. Next one. 4x minus 1 over 2 times x minus 3 minus x plus a minus x plus a over 2 times x minus 3. So for addition, subtraction, if two fractions have the same denominator, we keep denominator the same. Add the numerator, subtract the numerator. We're doing subtraction. So keep denominator the same. Subtract the numerator. We have 4x minus 1 minus x plus a. Then we try to simplify the numerator. We try to eliminate the parentheses first, then combine like terms. For 4x minus 1, if there's no operator in the front of the parentheses, we drop the parentheses without making any change. 4x minus 1. For the second part, when we see subtraction in the front, we treat this subtraction as negative sign. If I distribute negative sign, I have negative x and negative a. 2 times x minus 3. Then combine like terms. 4x minus 1x is 3x. If I combine like terms, 4x minus 1x is 3x. If I combine the numbers, negative 1 plus negative 8. Negative 1 plus negative 8 is negative 9. I leave the denominator the same. For the numerator, 3x minus 9, I can factor, pull out 3. 3 is the largest number that divides both 3 and 9. If I pull out 3 from the first term, there's x left. For the second term, 9 divided by 3 is 3. Leave the denominator the same. Then we can see that here, x minus 3 looks exactly the same. I can cancel x minus 3. If I cancel x minus 3, what's left is 3 over 2. That's the final answer. Next, let's look at some example that's a little different. Or if there's a different denominator, how do we add fractions with different denominators? S plus 9 over s squared minus 9 plus 1 over x plus 3. How do we add fractions with different denominator? What should we do here? When we add fractions with different denominator, what should we do? 1 over 6 plus, say, 1 over 2. How do we add fractions with different denominator? We first of all find the least common denominator first. For 6 and 2, the least common multiple is 6. So first fraction has 6 on the bottom, I leave it the same. For the second fraction, if I want to make 2 to be 6, if I want to make 2 to be 6, I need to multiply 2 by 3, then do the same thing to the top. So on the bottom, 2 times 3 is 6. On the top, 1 times 3 is 3. We make them the same denominator. Then I can add the numerator. 1 plus 3 is 4. Then simplify. 4 over 6 can be reduced as 2 over 3. Another example. 2 over 7 plus 5 over 14. We first of all find the least common multiple first. least common multiple of a denominator. That's called least common denominator, which represent the least common multiple of the denominator. For 7 and 14, least common multiple is 14. In order to make 7 to be 14, I need to multiply 7 by 2 and do the same thing to the top. On the top, 2 times 2 is 4. For the second fraction, we have 14 already. 14 is the same as LCD, so don't make any change. Keep the top the same. Since I keep the bottom the same, also keep the top the same. Then they have the same denominator. I can add the numerator. 4 plus 4 is 9. Denominator is 14. This cannot be reduced, so I leave it the way it is. Now observe this expression here. X plus 9 over x squared minus 9 plus 1 over x plus 3. How do we find the least common multiple of denominator? We first of all factor the denominator. Factor every denominator first. Factor every denominator first. This denominator, x squared minus 9, can be factored as x squared minus 9. How do we factor here? S squared minus 9. S squared is a perfect square. Number 9 is 3 times 3, which is also perfect square. That's difference of perfect squares. That can be factored as x plus 3 times x minus 3. That's the factor form of the denominator. X plus 3 times x minus 3. If I factor denominator, that's what I get here. Second fraction is 1 over x plus 3. So here, what's the least common denominator? Least common denominator must contain all factors. Least common denominator must contain all factors of the denominator. So here, the least common denominator must contain all factors. We have x plus 3 and x minus 3. The least common denominator must contain all factors of the denominator. X plus 3, x minus 3. So here, if once I find the least common denominator, I try to rewrite every fraction over the least common denominator. I try to rewrite every fraction over the least common denominator. So rewrite every fraction over the least common denominator. For the first fraction, the denominator is the same as the least common denominator, so don't make any change. For the first fraction, its denominator is the same as the least common denominator, so don't make any change. I leave it as x plus 9 over x plus 3 times x minus 3. Don't make any change. For the second fraction, compare the denominator with the least common denominator. If I compare the denominator with LCD, we can see that what's missing is x minus 3. If we compare this denominator with LCD, we can see that what's missing is x minus 3. If I compare this denominator with LCD, we can see that what's missing is x minus 3. So we multiply the missing factor to the top and the bottom. We multiply the denominator with the missing factor x minus 3. If I multiply x minus 3 to the bottom, I need to multiply the same thing to the top. So this fraction, it can be rewritten as x plus 9 over x plus 3 times x minus 3 plus 1 times x minus 3 over x plus 3 times x minus 3. Now they have the same denominator. We can keep denominator and put the numerator together. Keep denominator, put the numerator together. We have x plus 9 plus 1 times x minus 3. Then try to eliminate the parentheses. Then we can try to eliminate the parentheses. For the first fraction, if there's no operation in the front, I can drop the parentheses without making any change. For the second fraction, I can distribute 1 into the parentheses. I have 1 times x is x, 1 times negative 3 is negative 3, over x plus 3 times x minus 3. Then combine like terms. Then we can combine like terms. On the top, x plus x is 2x. 9, positive 9 plus negative 3 is positive 6. If I combine like terms, positive 9 plus negative 3 is positive 6. Leave denominator the same. Now here, if I factor numerator 2x plus 6, (2x plus 6 can be factored as 2 times x plus 3. For the numerator, I can pull out 2. 2 is the common factor for 2 and 6. That's the largest number that divides both 2 and 6. If I pull out 2, for the first term, if I pull out 2, I have x left. For the second term, if I pull out 2, 6 divided by 2 is 3. That's the numerator. Next, I leave the denominator the same. X plus 3 times x minus 3. Then I can cancel x plus 3 from top and the bottom. Cancel x plus 3 from top and the bottom. After cancellation, what's left is 2 over x minus 3. That's the final answer. Next example, x minus 7 over x squared plus x minus 2 minus 3 over s plus 2. First step, when we're doing addition and subtraction, we try to find the least common denominator first. So factor every denominator first. When we're doing when we're doing addition and subtraction for rational expressions, factor every denominator first. If I try to factor this denominator here, this is a trinomial with no leading coefficient, so I can draw two parentheses, find two numbers. When we multiply, we get negative 2. When we add, we get positive 1. Find two numbers. When we multiply, we get negative 2. When we add, we get positive 1. We can use 1 and 2. Negative 1, positive 2. Negative 1 plus positive 2 is positive 1. When I multiply, negative 1 times positive 2 is negative 2. So this two number works. So I can write s minus 1, s plus 2 in the parentheses. That's the factor form of this denominator. Second fraction stays the same. Next, we try to find the least common multiple of the denominator. Let's call LCD. LCD must contain all factors on the bottom. LCD must contain all factors on the bottom. On the bottom, we have x minus 1. We also have s plus 2, only divided once. On the bottom, we have s plus 1. We also have s plus 2. S minus 1, s plus 2. Only divided once. Only divide s plus 2 once. That's the least common denominator. Next, we try to rewrite every fraction over the least common denominator. Next, we try to rewrite every fraction over the least common denominator. For the first fraction, since the denominator looks exactly the same as LCD, I don't make any change. Since the denominator looks exactly the same as LCD, I don't make any change. For the second fraction, the denominator is x plus 2. If we compare the denominator with LCD, we can see that what's missing here is x minus 1. If we compare the denominator with LCD, we can see that here, what's missing is s minus 1. We multiply the missing factor to the top and the bottom. Multiply the missing factor to the top and the bottom. After we multiply, we can see that the denominator now looks exactly the same. After we multiply, we can see that Now the denominator looks exactly the same. So if they look exactly the same, only write it once. If they look exactly the same, only write it once. S minus 1, S plus 2. Write denominator only once. Put both numerator together. First numerator is x minus 7. Second numerator is minus 3 times x minus 1. First numerator is x minus 7. Second numerator is minus 3 times x plus 1. Then we try to simplify the numerator here. Simplify the numerator. If I simplify the numerator, I have x minus 7. If there's no operation in the front, I can drop the parentheses without making any change. For the second parenthesis, I can distribute negative 3 into the parentheses. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Then combine like terms. Combine like terms. 1x plus negative 3x. 1x plus negative 3x. When we combine like terms, add the coefficient. 1 plus negative 3 is negative 2. I get negative 2x. 1x plus negative 3x, I get negative 2x. Combine like terms for negative 7 and positive 3. Combine like terms for negative 7 and positive 3. Negative 7 plus positive 3 is negative 4. Then we can try to factor. Common factor for 2x and negative 4 is 2. Since the first term is negative, I pull out negative sign. Then for the first term, if I pull out negative 2, what's left is x. For the second term, negative 4 divided by negative 2 is positive 2. So that's the factor form of the numerator. So I simplify numerator, factor completely. That's my numerator. My numerator is negative 2 times x plus 2. Denominator is s minus 1 times x plus 2. That's my simplified numerator. I simplify numerator and factor completely. I get this numerator. Then I can cancel s plus 2 from top and the bottom. Then I can cancel s plus 2 from the top and the bottom. After cancellation, we have negative 2 over x minus 1. That's the final answer. Next example, x over s plus 2 plus 2 over x plus 3. First step, we try to factor each denominator. First step, we try to factor each denominator. Then find the common factors. But here, both denominators are not factorable. So we can try to find the least common denominator directly. If both of them cannot be factored, we can try to find the least common denominator directly. This common denominator must contain every factor on the bottom. This common denominator must contain every factor on the denominator. Here we have x plus 2 on the denominator and x plus 3 on the denominator. That's the least common denominator. Now we try to rewrite both fractions, put it over the least common denominator. Next, rewrite both fractions. Put both fractions over the least common denominator. For first fraction, we have x over x plus 2. If I compare the denominator with LCD, we can see that what's missing is s plus 3. If I compare the denominator with LCD, what's missing is s plus 2. So we multiply the missing factors from the top and the bottom. I multiply x plus 3 to the bottom. If I multiply x plus 3 to the bottom, I have to multiply it to the top. Second fraction, if you compare the denominator of LCD, you compare the denominator of LCD, we can see that what's missing is s plus 2. What's missing is s plus 2. So we multiply the missing factor to the top and the bottom. Now after we multiply, now both fractions have the same denominator. After we multiply, both fractions have the same denominator. So only if they have the same denominator, only write it once. S plus 2, s plus 3, that's the denominator. For numerator, we put everything together. For numerator, put all numerator together. We have x times x plus 3 plus 2 times x plus 2. Then simplify the numerator. Simplify the numerator and factor completely. Simplify the numerator and factor completely. For this numerator, we have x squared plus 3x. If I distribute x, I have x squared plus 3x. Plus, if I distribute 2, I have 2x plus 4. Then combine like terms. Combine like terms. We have x squared plus 5x plus 4. Combine like terms. 2x plus 3x plus 2x is 5x. Then we can try to factor this trinomial. There's no leading coefficient in the front. I can split s squared, put s on each parenthesis. Then I try to find two numbers that they multiply to be 4, add to be 5. The only possibility is 1 and 4. Positive 1 and positive 4. Positive 1 plus positive 4 is positive 5. And positive 1 plus positive 4. And positive 1 times positive 4 is 4. So this two number works. Put both numbers in the parentheses. Put positive 1, positive 4 in the parentheses. That's the factor form of the numerator. Put it here. We simplify numerator and factor, we get this. Put it here. We have x plus 1 times x plus 4. That's the factor form of the numerator. Denominator is s plus 2 over s plus 3. Now observe, can we cancel anything? Can we cancel anything from top and the bottom? If nothing can be cancelled, that's your final answer. If nothing can be cancelled, that's your final answer. We leave it the way it is. Next. X over x plus 4 minus 3 over x minus 1. So when we try to add or subtract rational expressions, we first of all try to factor the denominator. Here, both denominators cannot be factored. If they both cannot be factored, we can find the least common denominator directly. This common denominator must contain all factors on the bottom. LCD must contain all factors on the bottom. So one of the factor is x plus 4. Another factor is x minus 1. So that's the least common denominator. Compare the first fraction with LCD. Compare the first fraction with LCD. On the denominator, we have s plus 4. What's missing is s minus 1. What's missing is s minus 1. So we multiply the missing factor to the top and the bottom. Multiply the missing factor to the top and the bottom. For the second fraction, if we compare the denominator with LCD, what's missing is s plus 4. What's missing is s plus 4. We multiply by the missing factor from the top and the bottom. Multiply the missing factor from the top and the bottom. Multiply the missing factor from the top and the bottom. Now, after we multiply, we can see that all denominators look exactly the same. After we multiply, we can see that all denominators look exactly the same. We have x plus 4 times s minus 1. On the numerator, we put everything together. We put all numerator together. For the numerator, put everything together. We have x times x minus 1 minus 3 times x plus 4. For the numerator, put everything together. X times x minus 1 minus 3 times x plus 4. Then simplify. Then we simplify. On the numerator, I can try to distribute x first. If I distribute x, I have x squared minus 1x. X squared minus 1x minus 3x minus 12. Then combine like terms. We have x squared negative 1x plus negative 3x is negative 4x. When we combine like term and the coefficient, negative 1 plus negative 3 is negative 4. Leave number 12 the same. Then factor. This is a trinomial with no leading coefficient. I can split x squared, put x on each parenthesis, then find two numbers that they multiply to be negative 12 and add to be negative 4. For number 12, we can try 2 and 6. Positive 2 times negative 6 is negative 12, and positive 2 plus negative 6 is negative 4. Put both numbers in the parentheses, positive 2 minus 6. That's the factor form of the numerator. So we simplify, combine like terms, factor, that's the numerator. Here, the numerator is x plus 2 times x minus 6. The denominator is x plus 4 over x minus 1. If there's a common factor, we cancel common factor. But here, if there's no common factor, we leave it the way it is. If there is common factor, we cancel common factor. If there's no common factor, we leave it the way it is. That's the final answer. If there's no common factor, leave it the way it is. That's the final answer. Next. Two over s squared plus 4x plus 3 plus 1 over s squared plus 7x plus 12. When we try to add or subtract rational expressions, always factor the denominator first. When we try to add or subtract rational expressions, always try to factor the denominator first. For the first fraction, if I factor the denominator, this is a trinomial with no leading coefficients. I can write x, I can split x squared, write x on each parenthesis. Next, I try to find two numbers that when I multiply, I get 3. When I add, I get 4. For number 3 here, the only possibility is 1 times 3. Since I try to get positive 4 here, I can make positive 1, positive 3. So positive 1, positive 3, when I add them, I get positive 4. When I multiply, I get 3. So this two number works. Put them in the parentheses. Keep the numerator the same. For the second fraction, same thing, factor denominator. Factor denominator. This is a trinomial with no leading coefficients. So I can split x squared, write x on each parenthesis. Next, we try to find two numbers. When we multiply, we get 12. When we add, we get positive 7. For number 12, the only possibility is 3 and 4. Since I try to get number 7 here, I can use positive 3, positive 4. And when I add a number, 3 plus 4 is 7. When I multiply, 3 times 4 is 12. So this two number works. Put both numbers in the parentheses. Keep the numerator the same. Next, we try to find the least common denominator. Least common denominator must contain all factors of the denominator. First fraction is x plus 1, x plus 3. Least common denominator must contain all common factors, all factors on the denominator. Least common denominator must contain all factors on the denominator. We have x plus 1, x plus 3. We have x plus 3 again, but don't repeat, like that only once. Next, we have x plus 4. That's the least common denominator. It must contain all factors on the denominator. Now, compare the first fraction with the LCD. If we compare the first fraction with LCD, we can see that on the denominator, what's missing is s plus 4. On the denominator, what's missing is s plus 4. So we multiply the missing factor to the top and the bottom. What's missing is s plus 4. We multiply the missing factor to the top and the bottom. For the second fraction, if we compare the denominator with LCD, for the second fraction, if we multiply the denominator with LCD, we can see that what's missing is s plus 1. What's missing is s plus 1. So we multiply the missing factors from the top and the bottom. After we multiply, we can see that the denominator now looks exactly the same. After we multiply, we can see that now the denominator looks exactly the same. So we have s plus 1, x plus 3, and s plus 4. That's the common denominator. Then we put the numerator together. 2 times s plus 4 plus 1 times x plus 1. 2 times s plus 4 plus 1 times s minus 1. Then simplify the numerator. On the numerator, I can distribute 2 first. If I distribute 2, I have 2x plus a. If I distribute 1, I have 1x plus 1. Then I can combine like terms. 2x plus 1x is 3x. Number a plus number 1 is number 9. Then I can try to factor. For 3x plus 9, I can try to factor by taking out the greatest common factor. I can try to pull out the greatest common factor. For 3 and 9, number 3 is the greatest common factor. That's the largest number that divides both 3 and 9. If I pull out 3 from first term, there's x left. If I pull out 3, there's x left. For the second term, take 9 divided by 3, that's 3. So on the numerator, if I distribute, combine like term, and factor, I get 3 times x plus 3. Denominator is s plus 1 times s plus 3 times s plus 4. Now we can see that here, x plus 3 looks exactly the same. X plus 3 looks exactly the same. I can cancel common factor. X plus 3. The final answer is 3 over s plus 1 times s plus 4. That's the final answer. Next, 1 over s squared minus 3x plus 2 minus 4 over x squared minus 4. So, first step, we try to factor every denominator first. When we try to add or subtract rational expressions, factor every denominator first. The first denominator is s squared minus 3x plus 2. It's a trinomial with no leading coefficients. I can write two parentheses, 3s squared, put it on each parenthesis. Then try to factor 2. We try to find two numbers that when we multiply, we get 2. When we add, we get negative 3. Let's factor 2. The only possibility is 1 and 2. Since I try to get negative 3 on the middle, I can make negative 1, negative 2. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 2 is positive 2. It's this 2 here. So this 2 number works. Put both numbers in the parentheses. Negative 1, negative 2. Put both numbers in the parentheses. That's the denominator. Leave the numerator the same. Second fraction. The denominator s squared minus 4. This is difference of perfect squares. S squared is a perfect square. Number 4 is 2 squared. So it can be factored as x plus 2 times s minus 2. S squared is x squared. Number 4 is 2 squared. So use the formula of difference of perfect squares. I get s plus 2 times s minus 2. Leave the numerator the same. Next, find the least common denominator. Next, we try to find the least common denominator. Least common denominator must contain every factor on the bottom. On the bottom, we have x minus 1, x minus 2, x plus 2. We have s minus 2 already, so don't repeat. We have s minus 2 already, don't repeat. That's the least common denominator. Next, compare each denominator with the least common denominator. Find out what's missing. For the first fraction, we have x plus 1 times s minus 2. If we compare the denominator with LCD, what's missing is s plus 2. If I compare the denominator with LCD, we can see that here. What's missing is s plus 2. We multiply the missing factor to the top and the bottom. For the second fraction, if we compare the denominator with LCD, what's missing is s minus 1. If we compare the denominator with LCD, what's missing is s minus 1. We multiply the missing factor to the top and the bottom. Then, when we multiply out, we have exactly the same denominator. When we multiply the denominator, we have exactly the same denominator. So if the denominator is the same, write it only once. S minus 1, S minus 2, S plus 2. If the denominator is the same, write it only once. Then we put both numerator together. We have 1 times S plus 2 minus 4 times S minus 1. Then we simplify the numerator. When we simplify the numerator, distribute 1 first. If I distribute 1, I get x plus 2. Then for the second part, distribute negative 2. I get negative 4x plus 4. Then combine like terms. X by itself is the same as 1x. If we combine like terms, add the coefficient. 1 plus negative 4 is negative 3. 1 plus negative 4 is negative 3. X stays the same. Then add 2 and 4. Number 2 plus number 4 is positive 6. Then factor. For 3 and 6, common factor is 3. Since the first term is negative, I can pull out negative 3. If I pull out negative 3 for the first term, there's x left. For the second term, we take positive 6 divided by negative 3. Positive 6 divided by negative 3 is negative 2. Positive 6 divided by negative 3 is negative 2. So after we simplify the numerator, we have negative 3 times x minus 2. So that's the numerator. Negative 3 times x minus 2. Let's now simplify the numerator. Denominator stays the same. S minus 1, S minus 2, S plus 2. Then here you can see that S minus 2 looks exactly the same. S minus 2 looks exactly the same. I can cancel S minus 2 from top and bottom. The final answer is negative 3 on the top over S minus 1 and x plus 2 on the bottom. That's the final answer. Number 9. 2x over x plus 3 plus 4. 2x over x plus 3 plus 4. First of all, when we have a fraction plus a whole number, we first of all put the whole number over 1. When we have a fraction plus a whole number, we first of all put the whole number over 1. Next, find the least common denominator. least common denominator must contain all factors on the bottom. Must contain all common factors on the denominator. On the denominator, we have x plus 3 and 1. But the thing is, if I multiply x plus 3 times 1, it's the same as x plus 3. X plus 3 times 1 is the same as x plus 3. So the least common denominator is x plus 3. Every number times 1 is a number itself. The least common denominator is x plus 3. Now, try to rewrite both fraction over the least common denominator. For the first fraction, the denominator is x plus 3. I leave it the same. For the second fraction, I need to make the denominator to be x plus 3. So I multiply the bottom by x plus 3. If I multiply the bottom by x plus 3, I need to multiply the same thing to the top. So for the second fraction, I need to make the denominator to be x plus 3. In order to make 1 to be x plus 3, I multiply 1 by x plus 3. And whatever I multiply to the bottom, multiply the same thing to the top. Now after we multiply, we can see that for both fractions, the denominator now looks exactly the same. For both fractions, the denominator now looks exactly the same. So if they look exactly the same, only write it once. X plus 3. On the numerator, put everything together. 2x plus 4 times x plus 3. Then we try to simplify this numerator. What do we get here? We have 2x. If I distribute 4, I get 4x plus 3. 4x plus 12. If I distribute 4, I get 4x plus 12. Then combine like terms. 2x plus 4x is 6x. If I factor for 6x plus 12, if I factor, I can pull out 6. 6 is the greatest common factor. That's the largest number divides both 6 and 12. If I pull out 6, for the first term, if I pull out 6, there's x left. For the second term, if I try to pull out 6, I take 12 divided by 6. 12 divided by 6 is 2. So if I factor the numerator, if I simplify numerator and factor, I get 6 times x plus 2. If I simplify and factor the numerator, I have 6 times x plus 2. So that's the numerator, 6 times x plus 2 over the denominator x plus 3. And they are different factors, they cannot be cancelled. So that's the final answer. If they are different factors and they cannot be cancelled, that's the final answer. Next, x minus 6 over x minus 5. X minus 6 over x minus 5. When we have a whole number subtracted by a fraction, we need to first of all put the whole number over 1. Then we need to find the least common denominator. For number 1 and x plus x minus 5, on the bottom, the least common denominator must contain every factors. The least common denominator must contain every factors. It must contain number 1 and x minus 5. But the thing is, 1 times every number, the number stays the same. 1 times x minus 5 is the same as x minus 5. So 1 times every number is a number itself. We don't write 1 here. If I multiply, 1 times x minus 5 is the same as x minus 5. So this is the least common denominator. Next, we try to rewrite every fraction, put it over the least common denominator. For the first fraction, if I compare the denominator with the least common denominator, what's missing is x minus 5. So I multiply x minus 5 to both the top and the bottom. For the second fraction, 6 over x minus 5. The denominator looks exactly the same as LCD, so I don't make any change. If the denominator looks exactly the same as LCD, we don't make any change, leave it the way it is. Now, after we multiply, we can see that both denominator looks exactly the same. After we multiply, we can see that both denominator looks exactly the same. So the least common denominator is x minus 5. Then we can put it together. For the numerator, put everything together. For the numerator, we put everything together. We have x times x minus 5 minus 6. For the numerator, put everything together. If we put everything together for the numerator, I can distribute x. If I distribute x, I have s squared minus 5x minus 6. If I distribute x, I have s squared minus 5x minus 6. Then I can try to factor this trinomial. This is a trinomial with no leading coefficient. I can put x on each parenthesis. Then try to find two numbers that when we multiply, we get negative 6. When we add, we get negative 5. For negative 6, we can try to use 1 and 5. 1 and 6. We try to use 1 and 6. Since we try to get negative 5 here, I can use positive 1, negative 6. Positive 1 plus negative 6 is negative 5. Positive 1 times negative 6 is negative 6. So these two numbers works. Put both numbers in the parentheses. I have positive 1 minus 6. So after I simplify the numerator and factor, I get this. The numerator, after I simplify and factor, I get x plus 1 times x minus 6. The denominator is x minus 5. Here we see that nothing can be cancelled. Nothing can be cancelled. So we need to know what it is. That's the final answer. If nothing can be cancelled, we need to know what it is. That's the final answer. Next, I'll show you how to solve rational equations. A rational equation is an equation that contains rational expression. A rational equation is an equation that contains rational expression. Let's look at a simple example first. How do we solve this equation? 4 over x minus 4 equal to 3 over x plus 7. When we have a fraction equal to fraction, we can cross multiply. That's a special case. When we have a fraction equal to fraction, we can cross multiply. If I cross multiply, I have 4 times x plus 7 equal to 3 times x minus 4. That's a special case. When we have a fraction equal to fraction, we can cross multiply. 4 times x plus 7 equal to 3 times x minus 4. Then I can simplify. Distribute 4, I get 4x plus 28. On the other side, distribute 3, I get 3x minus 12. Then solve the equation for x. I can subtract 3x from both sides. On the right side, 3x and negative 3x can cancel. On the left side, 4x and negative 3x, if I combine like term, I get 1x. 28 stays the same, and negative 12 on the right side. Then I try to get s by itself. Subtract 28 from both sides. Negative 28, positive 28 can cancel. On the right side, negative 12 plus negative 28, if we combine like terms, they have the same sign. Keep the sign, add the magnitude. 12 plus 28 is 40. So the answer is s equal to 40. For rational equation, be very, very careful. We need to make sure this answer doesn't make the denominator equal to 0. If this answer makes the denominator equal to 0, this is not a solution. If this answer makes the denominator equal to 0, this is not a solution. We have to reject this solution. But here, when s is negative 40 minus 4 is not 0. Negative 40 plus 7 is also not 0. So this is solution. Answer is negative 40. The answer is negative 40. Next. 10 over x minus a equal to 5. 10 over s minus a equal to 5. When we have a fraction equal to a whole number, I can rewrite the whole number over 1. I can rewrite 5 as 5 over 1. I can rewrite 5 as 5 over 1. Then I can cross multiply. 10 times 1 is 10. 5 times s minus a, I leave it for now. 10 times 1 is 10. S minus a times 5 is 5 times s minus a. Cross multiply. Then simplify. I can distribute 5. I get 5x minus 5 times a is 40. Then I try to move 40 over. Get s by itself. Add 40 to both sides. Add 40 to both sides. I have 5x left on the right side. On the left side, 10 plus 40 is 50. Next, in order to get s by itself, I can divide both sides by 5. If I divide both sides by 5, x is 50 over 5 is 10. Now make sure the bottom is not 0. If I plug in 10 for x, 10 minus a is not 0. So this is the solution. If the solution makes the denominator equal to 0, we must reject this solution. So here make sure 10 minus a, if I plug in 10 to the denominator, 10 minus a is not 0. So this is the solution. Next example. Five over x plus 1 equal to 3 minus 7 over x plus 1. 5 over x plus 1 equal to 3 minus 7 over x plus 1. Now in this situation, we don't have fraction. We don't have a single fraction on the right side, so we can cross multiply. In this situation, we don't have a single fraction on the right side. We can cross multiply. In this situation, find the least common denominator first. Find the least common denominator. When we see a whole number, first of all, put the whole number over 1. Then try to find the least common denominator. Least common denominator must contain every factors. Least common denominator must contain every factors. So we have s plus 1 and 1. We have s plus 1 and 1. S plus 1 times 1 is s plus 1. S plus 1 times 1 is s plus 1. So find the least common denominator for every fractions. We find it is s plus 1. Next, try to rewrite every fraction over s plus 1. First fraction already have s plus 1. I leave it the same. Second fraction is 3 over 1. If I try to make denominator to be s plus 1, if we try to make denominator to be s plus 1, I multiply denominator by s plus 1. Then multiply the same thing to the top. The third fraction, since the denominator is s plus 1, I don't make any change. Now here we can see that every fraction have the same denominator. Every fraction has the same denominator. Now, be very, very careful here. When every fraction has the same denominator, we drop the common denominator. When every fraction has the same denominator, we drop the common denominator. When we make every denominator exactly the same, we drop the common denominator. So we have 5 equal to 3 times x plus 1 minus 7. When every denominator looks the same, we drop the common denominator. When every denominator looks the same, we drop the common denominator. We have 5 equal to 3 times x plus 1 minus 7. Then solve the equation for x. Distribute 3 first. We have 3x plus 3 minus 7. Combine like terms. Positive 3 plus negative 7 is negative 4. Positive 3 plus negative 7 is negative 4. Then we try to get s by itself. Try to get s by itself. 5 equal to 3x minus 4. Try to get s by itself. 5 equal to 3x minus 4. We try to get s by itself. So 5 equal to 3x minus 4. We try to get s by itself. I can add 4 to both sides. 5 plus 4 on the left side is 9. Negative 4 and positive 4 get cancelled on the right side. We get 3s by itself. In order to get s by itself, we divide both sides by 3. Here on the left side, 9 divided by 3 is 3. On the right side, 3 and 3 get cancelled. We get s by itself. So the answer is s equal to 3. The answer is s equal to 3. Now check the answer. If I plug in 3 to the denominator, 3 plus 1 is not 0. 3 plus 1 is not 0. So this 3 is valid. This is valid. If I plug in 3, it make 1 of the denominator 0. This answer must be rejected. If I plug in 3, it make 1 of the denominator 0. This answer must be rejected. So here, when I plug in 3, both denominators are not 0. If they are not 0, this answer is valid. This answer is valid. So the answer is 3. Next. X over x minus 3 plus 2 equal to 5 over x minus 3. So when we have a fraction and whole number, if an equation involves fraction and whole number, we first of all put the whole number over 1. If an equation involves fraction and whole number, we first of all put the whole number over 1. Number 2 can be rewritten as 2 over 1. Number 2 can be rewritten as 2 over 1. Then next we find the least common denominator. Least common denominator must contain every factor on the denominator. Least common denominator must contain every factor on the denominator. Here the factor on the denominator is x minus 3, 1, and x minus 3. So least common denominator must contain 1 and x minus 3. And we know that 1 times x minus 3 is the same as x minus 3. We don't write 1 in general. 1 times x minus 3 is the same as x minus 3. We don't write 1 in general. So we have x minus 3 as the least common denominator. Next, try to rewrite every fraction over the LCD. Next, try to rewrite every fraction over the least common denominator. First fraction, I leave it the same. Second fraction, we have 2 over 1. If I try to make 1 to be the same as x minus 3, I need to multiply 1 by x minus 3 and do the same thing to the top. Whatever we multiply to the bottom, we have to multiply the same thing to the top. The third fraction already has x minus 3 on the bottom, so don't make any change. Now, if we multiply, we can make every denominator look exactly the same. If we multiply the denominator, we can make every denominator look exactly the same. For rational equation, if we can make all denominator look the same, we are allowed to drop the common denominator. For rational equation, if we can make all denominator exactly the same, we can drop the common denominator. So if I drop the common denominator, we have 3 plus 2 times x minus 3 equal to 5. For equations with the same denominator, we can always drop the common denominator. If we drop the common denominator, what's left is 3 plus 2 times x minus 3 on the top equal to 5. Then we can simplify, solve an equation for x. I can first of all distribute 2. I have 3 plus 2x minus 6 distribute 2. 3 plus 2x minus 6 equal to 5. Next, I can combine like terms. Positive 3 plus negative 6. Positive 3 plus negative 6 is negative 3. Positive 3 plus negative 6 is negative 3 equal to 5. Next, we can solve this equation for x. We have 2x minus 3 equal to 5. I can first of all add 3 to both sides. If I add 3 to both sides, on the left side, negative 3, positive 3 can cancel. We have 2x by itself. On the right side, 5 plus 3 is a. On the right side, 5 plus 3 is a. In order to get s by itself, I can divide both sides by 2. So on the left side, number 2 on the top and the bottom can cancel. I get s by itself. On the right side, a over 2 is 4. And if I plug in 4 into the denominator, if we plug in 4 into the denominator is not 0. Or we can plug in 4 into the LCD. LCD is not 0. If I plug in 4 into the LCD, LCD is not 0. That means this answer is valid. If I plug in 4, it makes the LCD 0. This answer is invalid. Here, when I plug in 4 into the LCD, 4 minus 3 is not 0. So this answer is valid. Answer is x equal to 4. Next, 4 over x plus 5 plus 5 over s minus 2 equal to 1. First step, we rewrite the whole number over 1. First step, if our equation involves fractions, we must rewrite every term as a fraction first. 4 over s plus 5 plus 5 over s minus 2, rewrite number 1 as 1 over 1. Next, we find the least common denominator. Least common denominator must contain every factor of the denominator. Least common denominator must contain every factor of the denominator. We have x plus 5 times s minus 2 times 1. But every number times 1 is a number itself. Every number times 1 stays the same. Every number times 1 stays the same. So we don't need 1 here. If denominator is 1, we don't need 1 here. So this is the least common denominator. We try to make every denominator look the same. Look the same as the least common denominator. For the first fraction, if we compare the denominator with LCD, what's missing is s plus 2. So we multiply the missing factor to the top and the bottom. Second fraction, if we compare the denominator with LCD, what's missing is s plus 5. We multiply the missing factor to the top and the bottom. The third fraction, the denominator is 1. If we try to make denominator the same as LCD, both factors are missing. So I multiply the top and the bottom by the missing factor. Multiplied by s plus 5, x minus 2. Since they are both missing, I multiply top and the bottom by s plus 5, s minus 2. Then after we multiply, we can see that every denominator looks exactly the same. After we multiply, we can see that every denominator looks exactly the same. When every denominator looks exactly the same, we can drop the common denominators. For any rational equation, when we make every denominator looks exactly the same, we can drop the common denominators. For any rational equation, if we make denominator looks exactly the same, we can drop the common denominators. So we have, what's left is 4 times s minus 2 plus 5 times s plus 5 equal to 1 times x plus 5 times s minus 2. So if we drop the common denominator, that's what's left. 4 times s minus 2 plus 5 times s plus 5 equal to 1 times s plus 5 times s minus 2. And we know that when the coefficient is 1, for any polynomial, when the coefficient is 1, we don't need to write 1. For any polynomial, when the coefficient is 1, we don't need to write 1. Next, we simplify each term individually. Simplify each part individually. For the first part, I can distribute 4. If I distribute 4, I have 4x minus 8. For the second part, if I distribute 5, I have 5x plus 25. Last part, distribute. If I distribute x, I have s squared minus 2x. If I distribute 5, I have 5x minus 10. We distribute every term in the first parenthesis into every term in the second parenthesis. I first will take x times x, take x times negative 2, then I take 5 times x, take 5 times negative 2. Distribute every term in the first parenthesis into every term in the second parenthesis. That's what I get here. Next, we try to combine like terms. On the left side, 4x plus 5x. If I combine like term, I get 9x. 4x plus 5x is 9x. We add a coefficient. Next, combine the constants, combine the numbers. Negative 8 plus 25. Negative 8 plus 25. When I combine like terms, negative 8 plus 25 is positive 17. On the right side, if we combine like terms, we have s squared, negative 2x plus 5x. Negative 2x plus 5x, if I combine like term, add a coefficient. Negative 2 plus 5 is positive 3x minus 10. Next, this is a quadratic equation. We try to move everything to one side. Make one side of an equation 0. This is a quadratic equation. This is a second degree equation. We try to move everything to one side. Make the other side 0. I can try to subtract 9x from both sides. If I subtract 9x from both sides, on the left side, positive 9x and negative 9x get cancelled. We get 17 by itself. On the right side, x squared stays the same. Positive 3x and negative 9x, if I combine like terms, positive 3 plus negative 9 is negative 6x minus 10. Then I can subtract 17 from both sides. On the left side, positive 17 and negative 17 get cancelled. We get 0. On the right side, we have x squared minus 6x. Positive 10, negative 10 plus negative 17. Negative 10 plus negative 17. Follow addition rule. Negative 10 plus negative 17 is negative 27. Then I can solve this equation by factoring. This is a trinomial with no leading coefficient. So I can put x on each parenthesis. Then try to find two numbers that when we multiply, we get negative 27. When we add, we get negative 6. We try to find two numbers. When we multiply, we get negative 27. When we add, we get negative 6. So for 27, we can try 3 times 9. We try to make the sum to be negative 6. So I can try to make positive 3, negative 9. Positive 3 plus negative 9 is negative 6. And positive 3 times negative 9 is negative 27. So these two numbers work. I put these two numbers in the parentheses. Positive 3, negative 9. Then, if the product of two factors equal to 0, we set both of them equal to 0. We set x plus 3 equal to 0 and x minus 9 equal to 0. Solve both equations. First equation, I can subtract 3 from both sides. I get s equal to negative 3. Solve the second equation. I add 9 to both sides. I get s equal to positive 9. Now let's check. If I substitute negative 3 into the LCD, negative 3 plus 5 is not 0. Negative 3 minus 2 is not 0. So this answer is valid. If I plug in negative 3 and make LCD 0, then this answer is invalid. Here I plug in negative 3. Negative 3 plus 4 is not 0. negative 3 minus 2 is also not 0. So this answer is valid. If I plug in 9, 9 minus 5 is not 0. 9 minus 2 is also not 0. So 9 is also valid. So the solution is either s equal to negative 3 or s equal to 9. There are two solutions. It's either s equal to negative 3 or s equal to 9. Next example. (2x over x plus 3 minus 2 over x minus 4 equal to 3. When we are solving rational equations, if an equation contains fraction, we must rewrite the whole number as a fraction first. If an equation contains fraction, we must rewrite the whole number as a fraction first. So 2x over x plus 3 stays the same. 2 over s minus 4 stays the same. We can rewrite 3 as 3 over 1. Next, we try to find the least common denominator. Least common denominator must contain every factor on the denominator. Least common denominator must contain every factor on the denominator. So it must contain x plus 3. It must contain s minus 4. It must contain number 1. But the thing is, every number times 1 is the number itself. Every number times 1 stays the same. So we don't need 1 here. Every number times 1 stays the same. We don't need 1 here. So this is the least common denominator. Next, we try to rewrite every fraction over the least common denominator. First fraction is 2x over x plus 3. If we compare the denominator with LCD, we can see that what's missing is s minus 4. What's missing is s minus 4. We multiply the missing factor to the top and the bottom. Multiply the missing factor to the top and the bottom. Second fraction, we have 2 over s minus 4. If we compare the denominator with LCD, what's missing is s plus 3. If we compare the denominator with LCD, we can see that here, what's missing is s plus 3. We multiply the missing factor to the top and the bottom. For the third fraction, we have number 1 on the bottom. If we compare the denominator with LCD, both factors are missing. Both factors are missing. So we multiply missing factor to the top and the bottom. We need to multiply both of them to the top and the bottom. Multiply both missing factor to the top and the bottom. Then, for any rational expressions, if every denominator looks the same, we can drop the common denominator. Here, when we multiply out, every denominator looks exactly the same. If every denominator looks exactly the same, we can drop the common denominators. So after we drop the common denominator, what's left is 2x times s minus 4. For the first term, what's left is 2x minus s, 2x times s minus 4. For the second term, we have 2 times x plus 3. For the third term, we have 3 times x plus 3 times x minus 4. For the third term, we have 3 times x plus 3 times s minus 4. Then we try to distribute and combine like terms. Next, we try to distribute and combine like terms. So I first of all distribute 2x. If I distribute 2x, I have 2x squared minus ax. If I distribute 2x, I have 2s squared minus ax. If I distribute 2 here, I have 2x minus 6. On the right side, 3 times s plus 3, s minus 4. We can try to simplify the parentheses first. Simplify this parentheses first. How do we simplify the parentheses here? We have x plus 3, s minus 4. Multiply these two parentheses first. If I multiply these two parentheses, I have x squared minus 4x plus 3x minus 12. Distribute x and distribute 3. I have s squared minus 4x plus 3x minus 12. Then combine like terms. We have s squared minus 1x minus 12. That's what we have after we multiply these two parentheses. So we have 3 times s squared minus 1x minus 12. If I distribute 3, I have 3x squared minus 3x minus 36. If I distribute, I have 3x squared minus 3x minus 36. On the left side, if I combine like terms, I have 2x squared minus 10x, negative ax and negative 2x. If I combine like term, follow addition rule, I get negative 10x. Negative 8 plus negative 2 is negative 10. Negative 6. Next, this is a second degree equation. We try to move everything to one side, making the other side 0. Then solve the equation by factoring. This is a second degree equation. We try to move everything to one side, making the other side 0. Then solve the equation by factoring. Here I can try to subtract 2x squared first. If I subtract 2x squared, on the left side, 2x squared can cancel. We get negative 10x minus 6. On the right side, 3x squared minus 2x squared is s squared minus 3x minus 36. Next, I can try to eliminate 10x. Add 10x to both sides. On the left side, positive 10x and negative 10x can cancel. We get negative 6 by itself. On the right side, negative 3x plus 10x, follow addition rule. Negative 3 plus negative 10 is positive 7. X stays the same, minus 36. Next, we can add 6 to both sides. On the left side, positive 6 and negative 6 can cancel. We have 0 on the left side. On the right side, x squared stays the same, 7x stays the same, negative 36 plus 6. If I combine like terms, follow addition rule, I have negative 30. Then we can try to solve this equation by factoring. This is a trinomial with no leading coefficients. We can draw two parentheses. Split x squared, put in both parentheses. Then try to factor negative 30. Can we find two numbers that they multiply to be negative 30, add to be number 7? Can we find two numbers that when we multiply we get negative 30, when we add we get positive 7? So here for 30 we can try, since we want to get 7 here, I can try 3 and 10. And we want to get positive 7, so we can make negative 3, positive 10. Let's check. Negative 3 plus positive 10 is positive 7. Negative 3 times positive 10 is negative 30. So this pair works. Put both numbers in the parentheses. We have negative 3 and positive 10. We have negative 3 and positive 10. Then, if two functions multiply to be 0, we set each of them equal to 0. We set x minus 3 equal to 0, x plus 10 equal to 0. If we solve the first equation, I can add 3 to both sides. On the left side here, positive 3, negative 3 can cancel, we can add by itself. On the right side, 0 plus 3 is 3. So first solution is s equal to 3. The second solution, I can subtract 10 from both sides. On the left side, positive 10, negative 10 can cancel, we can add by itself. On the right side, 0 minus 10 is negative 10. And let's check the answer. If I plug in 3 into the LCD, 3 plus 3 is not 0. If I plug in 3 here, 3 minus 4 is also not 0. So this answer is valid. If I plug in 3, it makes 1 of them 0. Then this answer is invalid. You must reject the answer. Here when I plug in 3, 3 plus 3 is not 0. 3 minus 4 is not 0. So this answer is valid. This answer is valid. If I plug in negative 10, negative 10 plus 3 is not 0. Negative 10 minus 4 is also not 0. So this answer is valid. When I plug in negative 10, the least common denominator is not 0. So this answer is valid. Both answers are valid. So there are two solutions. There are two solutions. Both answers are valid. There are two solutions. S equal to 3 or S equal to negative 10. There are two solutions. And they are both valid. Next example. 3 over S plus 4 equal to 4 over S plus 2 minus 5 over x squared plus 6x plus a. So when we are solving rational equation, try to find the least common denominator first. In order to find the least common denominator, we have to factor every denominator if possible. In order to find the least common denominator, we have to factor every denominator if possible. So first denominator, s plus 4, this is not factorable, we leave it the way it is. Second denominator is s plus 2. This is not factorable, we leave it the way it is. Third fraction, the denominator is s squared plus 6s plus a. This is factorable, we can try to factor this. It's a trinomial and there's no leading coefficient. We can split s squared, write it as x times x. Split s squared, write it as s times x. Next, we try to find two numbers that when we multiply, we get a. When we add, we get 6. Find two numbers that when we add them, we get positive a. When we multiply them, we get positive 6. For number a, we can try 2 and 4. Since we try to get positive 6 here, we can try positive 2 and positive 4. Let's check. Positive 2 plus positive 4 is positive 6. When we multiply, 2 times 4 is a. So this two number works. Put both numbers in the parentheses. Next, we try to find the least common denominator. Next, we try to find the least common denominator. The least common denominator must contain every factors. It must contain every factors. So we have x plus 4, we have x plus 2, we have x plus 2, but we have it already, don't repeat, we have it already. Next we have x plus 4, again we have it already, don't repeat, we have it already. So this is the least common denominator. Next, rewrite every fraction over the least common denominator. Next, rewrite every fraction, put it over the least common denominator. For the first fraction, 3 over s plus 4. If we compare the denominator of LCD, we can see that what's missing is s plus 2. What's missing is s plus 2. So we multiply the missing factor to the top and the bottom. For the second fraction, we have 4 over s plus 2. If we compare the denominator of LCD, we can see that what's missing is s plus 4. What's missing is s plus 4. We multiply the missing factor to the top and the bottom. Multiply the missing factor to the top and the bottom. For the third fraction, 5 over s plus 2 times s plus 4. If we compare the denominator of LCD, we can see that it looks exactly the same. So don't make any change. If it looks exactly the same, we don't make any change. If the denominator looks exactly the same as LCD, don't make any change. Leave it the way it is. Now, if we multiply the denominator, we can see that every denominator looks exactly the same. For rational equations, if every denominator looks exactly the same, we can drop common denominators. For rational equation, if every denominator looks exactly the same, we can drop the common denominators. If we drop the common denominator, what's left is 3 times s plus 2 equal to 4 times s plus 4 minus 5. If we drop the common denominator, what's left is 3 times s plus 2 equal to 4 times s plus 4 minus 5. Then solve the equation for x. Then we solve the equation for x. I can distribute 3 first. If I distribute 3, I get 3x plus 6. Next, I distribute 4. If I distribute 4, I get 4x plus 16 minus 5. Then I can combine like terms. (16 minus 5 is 11. Next, when we have x on both sides of the equations, we can try to group x to the same side. Usually, we try to group x to the left side. So in this problem, if we group x to the right side, it will be easier. If I subtract 3x from both sides, on the left side, 3x get cancelled. Positive 3x, negative 3x get cancelled. We have number 6 by itself. On the right side, 4x minus 3x. 4 minus 3 is 1. If I combine like terms, positive 4 plus negative 3 is 1. I get 1x. 1x is the same as x. Since I get x here, that's why I say it's easier to group x to the right side. But in general, I group x to the left side. In this particular equation, since grouping x to the right side, I have positive x here, I have 1x here. It's easier. That's why in this particular problem, I group x to the right side. Next, in order to get s by itself, I subtract 11 from both sides. If I subtract 11 from both sides, positive 11, negative 11 can cancel. I get s by itself. On the left side, positive 6 plus negative 11 is negative 5. If I combine like terms, positive 6 plus negative 11 is negative 5. So the answer is s equal to negative 5. Check the answer. If I substitute negative 5 into the LCD, negative 5 plus 4 is not 0. Negative 5 plus 2 is also not 0. So this answer is valid. Otherwise, if negative 5 make one of the factor 0, this answer is invalid. But here, when I plug in negative 5 plus 4 is not 0. Negative 5 plus 2 is also not 0. So this answer is valid. The answer is s equal to negative 5. That's the solution to this equation. Next, 2 over x minus 3 plus 3 over s minus 1 equal to 4 over s squared minus 4x plus 3. 2 over s minus 3 plus 3 over s minus 1 equal to 4 over s squared minus 4x plus 3. When we are solving rational equations, we try to find the least common denominator first. In order to find the least common denominator, we must factor every denominator first. So let's factor every denominator first. For the first fraction, 2 over x minus 3, this denominator cannot be factored, so I leave it the way it is. Second fraction, 3 over s minus 1. This denominator cannot be factored, I leave it the way it is. For the third fraction, we have x squared minus 4x plus 3 on the bottom. This is a trinomial with no leading coefficient. It's factorable. Let's factor the denominator. S squared can be split as x times x. Next, I try to find two numbers that when I multiply, I get 3. When I add, I get negative 4. We try to find two numbers that when we multiply, we get 3. When we add them, we get negative 4. We can try to use 1 and 3. Since I try to get negative 4 here, I make negative 1, negative 3. Let's check. Negative 1 plus negative 3 is negative 4. Negative 1 times negative 3 is positive 3. So this two number works. Put both numbers in the parentheses. Next, we try to find the least common denominator. Least common denominator must contain every factor of the denominator. Least common denominator must contain every factor of the denominator. So we have x minus 3, x minus 1, S minus 1, we have it already. S minus 3, we have it already. So this is the least common denominator. Next, we try to rewrite every fraction over the least common denominator. Next, try to rewrite every fraction over the least common denominator. For the first fraction, 2 over x minus 3. If we compare the denominator of LCD, we can see that what's missing here is x minus 1. So we multiply the missing factor to the top and the bottom. Second fraction, 3 over x minus 1. If we compare the denominator with LCD, we can see that what's missing is x minus 3. So we multiply the missing factor to the top and the bottom. The third fraction, if we compare the denominator with LCD, nothing is missing. It looks exactly the same. If we compare the denominator with LCD, it looks exactly the same. If it looks exactly the same, we leave it the way it is. If the denominator looks exactly the same as LCD, we leave it the way it is. Now, we can see that if I multiply the denominator, we get the same denominator everywhere. If we multiply, we get the same denominator everywhere. For any rational expression, if the denominator looks exactly the same, we can drop the common denominator. For any rational expression, if the denominator looks exactly the same, we can drop the common denominator. So here we can drop the common denominator. We have 2 times s minus 1 plus 3 times x minus 3 equal to 4. If we drop the common denominator, we have 2 times s minus 1 plus 3 times s minus 3 equal to 4. Then we can solve the equation for x. If I distribute 2, I have 2x minus 2. If I distribute 3, I have 3x minus 9 equal to 4. Then I can combine like terms. 2x plus 3x. If I add the coefficient, 2 plus 3 is 5. I get 5x. Combine like terms from the numbers. Negative 2 plus negative 9. Negative 2 plus negative 9 is negative 11 equal to 4. Next, we try to get s by itself. So I can add 11 to both sides. On the left side, positive 11, negative 11 can cancel. We get 5s by itself. On the right side, 4 plus 11 is 15. In order to get s by itself, I can divide both sides by 5. On the left side, positive 5 on the top and the bottom can cancel. We get s by itself. On the right side, 15 over 5 is 3. So the solution is s equal to 3. Let's check the answer. If I substitute 3 into the LCD, 3 minus 3 is 0. 0 times everything is 0. So if I plug in 3, LCD is 0. If I plug in 3, LCD is 0. If I plug in 3, LCD is 0. That means this answer is invalid. This answer is invalid. It must be rejected. If I substitute 3 into the LCD, it's 0. If I plug in 3 into the LCD, it makes LCD 0. This answer must be 0. So when s equal to 3, the LCD is 0. So 3 must be rejected. This solution must be rejected. If there's only one solution and this solution is rejected, that means this equation has no solutions. Therefore, it has no solutions. This equation has no solution. We only find one solution, and this solution makes LCD 0. It will be rejected. If we only find one solution and it's rejected, there's no solution. If we only find one solution and it's rejected, that means this equation has no solutions. Next, 2x over x plus 3 minus x over x minus 5 equal to 48 over s squared minus 2x minus 15. When we are solving rational equations, we need to find the least common denominator. In order to find the least common denominator, we need to factor every denominator first. First denominator is s plus 3. It cannot be factored. First denominator is s plus 3. This is not factorable, so I leave it the way it is. Second denominator is s plus 5. Again, it's not factorable. I leave it the way it is. Third fraction, the denominator is a trinomial with no leading coefficient. I can try to factor this denominator. S squared can be factored as x times x. If I split s squared, I can make x times x. Next, I try to find two numbers that when I multiply, I get negative 15. When I add, I get negative 2. For 15, we can try 3 times 5. Since we want to get negative 2 here, we can make positive 3, negative 5. Put both numbers in the parentheses. Positive 3, negative 5. Next, we can try to find the least common denominator. Least common denominator must contain every factor on the denominator. Least common denominator must contain every factor on the denominator. We have x plus 3, s minus 5, s plus 3, s minus 5. Next, we need s plus 3. S plus 3, we have it already. Don't repeat. Next, we need s minus 5, which also have it already. Don't repeat. So this is the least common denominator. Next, try to make every fraction over the least common denominator. First fraction is 2x over x plus 3. In order to make denominator the same as LCD, we multiply the denominator by what's missing. Here. Here, what's missing is s minus 5. I multiply by the missing factor s minus 5 to the top and the bottom. Next, x over s minus 5. We multiply the denominator by the missing factor. The missing factor is x plus 3. Multiply the missing factor to the top and the bottom. Last term. The denominator looks exactly the same as LCD, so don't make any change. The last term. When the denominator looks exactly the same as LCD, don't make any change. Leave it the way it is. Then we can see that if we multiply the denominator, they all look exactly the same. So for any rational expression, if the denominator looks exactly the same, we can drop the common denominator. For any rational equation, if the denominator looks exactly the same, we can drop the common denominators. So in this problem, if we drop the common denominator, what's left is 2x times s minus 5 minus x times x plus 3 equal to 48. If we drop the common denominator, what we have is 2x times s minus 5 minus x times x plus 3 equal to 48. Next, we need to solve an equation for x. Distribute first. Let me distribute first. If I distribute 2x, I have 2s squared. Distribute 2x. 2x times negative 5 is negative 10x. 2x times negative 5 is negative 10x. X times x, negative x times x is negative s squared. Negative x times 3 is negative 3x equal to 48. Next, we can combine like terms. 2s squared minus 1x squared. If there's no coefficient, some coefficient is 1. 2s squared minus 1s squared. We combine like terms. Positive 2 plus negative 1. Positive 2 plus negative 1 is positive 1. We get 1x squared. Then another like term is 10x, negative 10x and negative 3x. Negative 10x and negative 3x. if I combine like term and the coefficient, negative 10 plus negative 3 is negative 13x equal to 48. This is a quadratic equation. This is a second degree equation. We try to move everything to one side. Make one side of an equation 0, then solve an equation by factoring. We try to make one side of an equation 0, then solve an equation by factoring. Here I can try to subtract 48 from both sides. Subtract 48 from both sides. On the right side, 48 minus 48 is 0. They get cancelled. 48 minus 48 is 0. On the left side, I can combine like terms. They have different variables. I can combine like terms. If I can combine like terms, I write this expression in descending order. If I can combine like terms, I write everything together in descending order. I have x squared minus 13x minus 48. Put it in descending order. This is a trinomial with no leading coefficients. I can split x squared, write it as x times x. Then I try to find two numbers. When I multiply, I get negative 48. When I add, I get negative 13. I try to find two numbers. When I multiply, I get negative 48. When I add, I get negative 13. 48, 13, that's not easy. That's not easy. Let's write down all possibilities first. 48 can be written as 1 times 48, 2 times 24, 3 times 16, 4 times 12, 4 doesn't work, 6 times 8. That's all possibilities for 48. We try to add and subtract each pair of numbers. See if we can get 13 here. The only possibility here is 16 minus 3 that gives me 13. So let's try to use 3 and 16. I try to make the sum to be negative 13. So I can try to use positive 3 and negative 16. When I add positive 3 plus negative 16 is negative 13. When I multiply, I get negative 48. So these two numbers works. Put both numbers in the parentheses, x plus 3, x minus 16. Then if the product of two factors equals 0, if two factors multiply to be 0, that means I set both of them equal to 0, solve an equation for x. So I have x plus 3 equal to 0, x minus 16 equal to 0. If I solve the first equation, I subtract 3 from both sides. S equal to negative 3. If I solve the second equation, add 16 to both sides. S equal to 16. Now let's check the answer. Make sure this answer doesn't make LCD equal to 0. Let's check the answer. If I substitute negative 3 into the LCD, negative 3 plus 3 is 0. Negative 3 plus 3 is 0. 0 times everything is 0. So when S equal to negative 3, LCD is 0. When S equal to negative 3, LCD is 0. So this answer is rejected. This answer is rejected. When S equal to negative 3, LCD is 0. When I substitute negative 3, it makes LCD 0. Negative 3 times plus 3 is 0. 0 times everything is 0. When I substitute negative 3, it makes LCD 0. So this answer must be rejected. Let's check the other answer. If I substitute 16, 16 plus 3 is not 0. 16 minus 5 is not 0. So this answer is valid. If I plug in 16, LCD is not 0. So this answer is valid. The only solution is S equal to 16. There's only one solution. This equation has only one solution, S equal to 16, because negative 3 is rejected. So there's only one solution, S equal to 16. Next, 3x over s minus 1 plus 2x over s minus 4 equal to 4s squared minus 40 over s squared minus 5x plus 4. when we are solving rational equations, we try to find the least common denominator first. In order to find the least common denominator, we need to factor every denominator first. So let's factor every denominator. First denominator is s plus 1. This is not factorable. Second denominator is s minus 4. It's also not factorable. The third denominator, this is a trinomial with no leading coefficient. This is factorable. Let's try to factor. S squared can be factored as x times x. Can we find two numbers that multiply to be 4, add to be negative 5? We can try to use 1 and 4. Since we want to get negative 5, I use negative 1 and negative 4. Let's check. Negative 1 plus negative 4 is negative 5. When we multiply, negative 1 times negative 4 is positive 4. So this two number works. Put both numbers in the parentheses, s minus 1, s minus 4. So the least common denominator is s plus 1, s minus 1. This common denominator must contain every factor on the bottom. It has s minus 1, s minus 4. S minus 1 is here already, don't repeat. S minus 4 is here already, don't repeat. So this is your least common denominator. This is the least common denominator. Next, we try to rewrite every term over the least common denominator. Rewrite every term over the least common denominator. First term, 3x over s minus 1. If we compare the denominator with LCD, we can see that what's missing is s minus 4. If we compare the denominator, we can see that what's missing is s minus 4. So we multiply the top and the bottom by the missing factors. Multiply the top and the bottom by the missing factors. Second factor, second term, 2x over s minus 4. If we compare the denominator with LCD, we can see that what's missing is s minus 1. If we compare the denominator with LCD, what's missing is s minus 1. We multiply top and the bottom by the missing factors. The third factor, 4s squared minus 40 over s minus 1 times s minus 4. If we compare the denominator with LCD, we can see that it looks exactly the same. The denominator looks exactly the same, so we don't make any change. If the denominator looks exactly the same as LCD, we don't make any change, leave it the way it is. So if we multiply everything out, we can see that every denominator looks exactly the same. When we are solving rational equations, if the denominator looks exactly the same, we can always drop the common denominator. So here, if we drop the common denominator, what's left is 3x times s minus 4 plus 2x times s minus 1 equal to 4s squared minus 40. If we drop the common denominator, we have 3x times s minus 4 plus 2x times x minus 1 equal to 4s squared minus 40. Next, we solve an equation for x. If I distribute 3x, I have 3x squared minus 12x. If I distribute 2x, I have 2s squared minus 2x equal to 4s squared minus 40. Next, I can try to combine like terms. 3s squared plus 2s squared. If I combine like term and a coefficient, I get 5x squared. Another pair of like terms is negative 12x and negative 2x. That's another pair of like terms. Negative 12x and negative 2x. That's another pair of like terms. If I combine like term and a coefficient, negative 12 plus negative 2 is negative 14. Like terms x, it stays the same. Equal to 4s squared minus 40. Next, we can see that this is an equation, second degree. This is a second degree equation. We try to make one side of the equation 0, then solve the equation by factoring. This is a second degree equation. We can try to make one side of the equation 0 first, then solve the equation by factoring. I can first of all try to make the right side 0. I can subtract 4x squared from both sides. if I subtract 4x squared on the left side, 5x squared plus negative 4x squared is 1x squared. If I combine like terms, I add a coefficient. Positive 5 plus negative 4 is positive 1. Positive 5 plus negative 4 is positive 1. If the coefficient is 1, we don't write 1. So 5x squared plus negative 4x squared is 1x squared. Minus 14x equal to, on the right side here, 4x squared and negative 4x squared can cancel. We have negative 40 left. Next, I can add 40 to both sides, make the right side 0. Add 40 to both sides. If I add 40 to both sides, on the right side, negative 40 plus 40 is 0. X squared minus 14x plus 40, they are not like terms. They are not like terms. They cannot be combined. If they cannot be combined, we write everything in descending order, which means the term with higher power come first. If they cannot be combined, write everything in descending order, which means the term with higher power come first. So we have x squared minus 14x plus 40. Now I make one side of an equation 0. I can try to solve an equation by factoring. And this is a trinomial with no leading coefficient. So I can draw two parentheses. Split x squared. I can split x squared as x times x. Next, we try to find two numbers. Like when we multiply, we get negative 40. When we multiply, we get positive 40. When we add, we get negative 14. We can try to use 10 and 4. We try to use 10 and 4. Since when we get negative 14, we can use negative 4 and negative 10. Let's check. When we add the numbers, negative 4 plus negative 10 is negative 14. When we multiply, negative 4 times negative 10 is positive 40. So this two number works. So use these two numbers. Put both numbers in the parentheses. We have negative 4 and negative 10. When two functions multiply to be 0, we set each of them equal to 0, then solve an equation for x. So we set x minus 4 equal to 0, x minus 10 equal to 0. Solve both equations for x. For the first equation, I can add 4 to both sides. I make x equal to 4. For the second equation, I can add 10 to both sides. I make s equal to 10. Now let's check the answer. If I substitute 4 into the LCD, 4 minus 1 is not 0. But 4 minus 4 is 0. 0 times everything is 0. When s equal to 4, LCD is 0. So this answer must be rejected. When s equal to 4, the LCD is 0. So this answer must be rejected. When s equal to 10, 10 minus 1 is not 0. 10 minus 4 is not 0. So this answer is valid. This answer is valid. The only solution here is s equal to 10. So there's only one solution. For this equation, there's only one solution. S equal to 10. There's only one solution. S equal to 10. Number 4 is rejected. There's only one solution. S equal to 10.